Okay, we're going to continue our journey through this chapter review, and in number 11 we are asked to simplify the expression. And again, as we look at this, we're going to inspect the denominator and then take a look at what's on the inside here and see if we can rewrite the number, not necessarily the variable, but the number with that same exponent. And so if you think about it, 81 can be converted to 3 to the 4th. And that'll be x to the 8th. And now we're going to raise it to the negative 3/4 power. And again, now you can distribute that power to everything on the inside. And when you do, when you distribute it to the first factor, the 4's cancel out and you're left with 3 to the negative 3rd. And then when you distribute it to the second factor, again, the 4 will strike out with the 8, and you'll have x to the negative 6. And you probably won't see the answer on a multiple choice test written like this, so let's just keep going on it. We want this to be happy exponents, and so to do so, we just change its position in the fraction. And right now it's in the numerator, so let's go ahead and put it in the denominator. 3 cubed is 27, and then I can pull that 6 to the denominator, and that will be your final answer. Number 12, if the bases are the same, you can add those powers together. I know you don't like to add fractions. Too bad. 3/4 plus 1/2. Well, 1/2 is nothing more than 2/4. Come on, people, you can do this. Add your numerators together, you get b to the 5/4 power. And make sure you lift that 5/4 up pretty good so that it looks like an exponent. Number 13, again, if we can write the numbers with the same power as the denominator of that fraction, it will make this a little bit easier. So again, I know that 9 is 3 squared, and that's going to be x to the negative 4th y squared, and now it's ready to distribute this negative 1/2. And again, when all the operations are multiplication or division, you can just do it. Just distribute that power. And when you take half of 2, you get 1, but it's a negative 1/2, so that's going to be 3 to the negative 1st. This is already a negative. When you take half of 4, you get 2. It's going to make that a positive 2 because a negative times a negative is a positive. And again, when you take half of 2, you get 1, but that's going to be a y equals y to the negative 1st. Let's make these present unhappy exponents happy. So we're going to change the position in the fraction. So the 3 is going to go to the downstairs of the fraction, and so is the y. And so your answer will be x squared over 3y. Number 14 looks a little bit complex. If upon inspection, I'm noticing that these two inside factors are both the same. One's just to a positive 1/2, one's to the negative 1/2. So how about if we take this second one and make this a happy exponent by putting everything in the downstairs? And when we do, we get 7a squared b cubed to the positive 1/2. Well, folks, anything divided by itself, yep, is equal to a 1, so it wasn't as hard as it looked. Okay. Next one, number 15. Solve each equation, check for extraneous roots. Alright, so first thing we want to do is to isolate the radical. It's been done. And so now what we want to do is raise this to the same power that's in the crook of the symbol. And then the golden rule says which we do to one side, we do to the other. And these will cancel each other out because they're inverse operations. We'll get x plus 5 is equal to 6 times 6 times 6, which is 216. And now we can subtract 5, and our answer is 211. And mentally check that to see if it is an extraneous root or an imposter, as we call them. If you plug this in, you get 216. And oh, by the way, let me back that up. Since this was an odd power, we don't have to check for extraneous roots, but we should check it to make sure that it's correct. So when you take 211 and add 5, you get 216. The cube root of 216 is 6, and it does check. Okay, this one we need to fix a little bit. Let me go over here and make this pen a little bit bigger. And so I need to isolate the radical. So I'm going to start by adding 1. And it might be a little too thick, but we'll try it. X plus 5 is equal to 3. Yeah, I got to bring that down a little bit. Okay, and now to undo the radical, remove the radical, we're going to lift it to the same number that's in the crook of the symbol. If you don't see it, it's implied 2. As a result of the squaring, we have just opened the door for extraneous roots. So we want to make sure that we check our answer. So let's do that. 4 plus 5 is 9. The square root of 9 is 3. 3 minus 1 is 2. We're good. All right, number 17. Again, isolate the rational part. It is isolated. So now what we can do again is raise it to the reciprocal power. Well, the reciprocal of 1/3 is 3. And the golden rule says what I do to one side, I must do to the other. And when I distribute this 3 to the 1/3, it becomes a 1. So really it releases the 2x minus 4 from that rational exponent. And 4 cubed is 64. And we're going to subtract 4 and get 60. And then divide by 2 and get 30. And so, again, we should probably check this, but for sake of time, let's move on. Since it was raised to a cube, you don't have to worry about extraneous roots. Number 18, all right? It's isolated. We don't have to move anything. And now we'll square it. And that'll lift off the radical. And we will take the 4 and bring it to the other side. And now we'll take the square root. Now there's going to be 2 answers on this one because we have a quadratic equation. So x, and again, I'm not going to go through the breakdown of this, but that has a 9 in it and a 5, and the square root of 9, this is what I'm doing, by the way, the square root of 9 is 3, so it's 3 root 5, but there's 2 answers, so don't forget to put plus and minus here. And we need to check these because for the extraneous root, because we did square it. So when I square the 3 root 5, I get 9 times 5, which is 45. 45 plus 4 is 49, and the square root of 49 is 7. Now when I plug in the negative, anytime you square negative, you get a positive, so it's going to be the same thing. So both of these answers are solutions to this equation. And I believe that wraps up this section. Yeah, let's end it here, and I'll continue on in another video with the rest of the other questions.